Good morning, everyone. So I am Arup Tarafdar, an associate software engineer working in the R&D department at Jeavio. And
And I am Hitarth Patel, and I am also Associate Software Engineer at Jeavio and working in R&D department.
so today we will be giving a session on agentic RAG and exactly how we can implement them in real life agentic systems. So this is not going to be a normal AI talk, theoretical, everything, all coding and boring. We are going to feel exactly how agentic RAG works, exactly how you can build your own systems. We will be also be creating our own agentic system. We will then explore multimodalities, how images, audios, videos can be transcribed, or they can be directly covered by the agent directly by embeddings. And in short, we will be feeling exactly how this system works. We'll also be feeling how we can compare them to humans, how humans think, how agents think, where do we need semantic retrieval and traditional RAG, where we need agentic RAG. So everything of this is going to be covered in this session in the upcoming slides.
All right. So first we'll cover that how RAG system started from the traditional RAG, a classic RAG, and then it evolved to the agentic RAG, and more than that, multi-agent systems. So we'll cover all the parts. Also, we cover that how agentic systems work, like how they retrieve, how they reason over retrieved context, and how they verify the context, and how it answers the correctly. And also we'll cover that how all the agents has the ability to cover all the formats, like not only text but images, videos, audios, and every other things. So we'll cover all the trade-offs as well, that when you need to use your classic reg, when you need to use agentic reg system, based upon your use case, whatever you need to use, we'll explain all the things in these slides.
So, just a quick disclaimer before we start the presentation that all the characters, events, and places appearing in this whole presentation are fictitious, and any resemblance to any real life characters or events is totally coincidental. So, I want you guys to just go through the whole story that we are building up. It is also something that you will have to remember. So, you have your notepads, you can just write it down, and we are just going to explore exactly how agents work. So, the Nilgiri Taj theft, case number 001. In Mumbai Institute of Fine Arts, on the day of 16th March 2025, on 9 o'clock and 8 minutes, a case was reported. What was the case? The Nilgiri Taj, made by Mr. Ramakrishna Pradhan in 1903, was stolen. A painting worth rupees 14.5 crore was stolen from a highly confidential and full of security based institute. The frame is still there, but the canvas of the painting is gone. And the most interesting part is that nobody in the premises saw anything, nobody in the premises even heard anything, and the whole alarm systems, the highly secure institute, did not went off. Then a sealed case landed on the desk of multiple detectives. We will uncover exactly how these detectives solved the case.
All right, so let's see what are the evidences that police have uncovered. Like, let me first tell you what exactly happened. So, the night before, when this theft happened, there was an conference at the space at the gallery, and this picture, this painting, which is Nilgiri Taj, was at the display position number 4 in the gallery D. So now all the paintings are there, and this conference is going on. So police have found out that the painting has been stolen in the morning in the next day, and that was reported by Mr. Vikram Singh, who is the head of security. Now police have found lot of evidences, like security logs, like forensic reports. Also, there were a lot of witnesses, so they have also found witness statements as well. And also they have found this shoe print, which is size of 9 UK, and that was found at the position of that painting. Also, they have uncovered some of the prime suspects. Like suspect number 1 was Vikram Singh, who had all the access to the all the doors. Suspect number 2 is Meera Joshi, so who was the art appraiser, and the third suspect, who is Rohan Kulkarni. So let's see what happens next and how this evidence helps the all the detectives in to uncover this case.
Let us see our suspect number one. Now, since you all have your notepad, I want you all to write down all the suspects, what are their clues, and how will they exactly, and what's your opinion on who would be the final culprit. We will be showing you who is the final culprit, but still, if you just write it down, we can then cross check if you are right or wrong. So the suspect number one is Vikram Singh. He is the head of security and has worked for 12 years at MIFA. They, all the evidences mostly lead up to him. Why? Because the alarm systems of the whole institute were deliberately slowed down just before the conference by Vikram Singh. What was his motive? It is still unknown. When the interrogation was happening, night watchman Pawar, who was at duty that night, testified against him. He said that he had seen Vikram Singh doing irregular patrolling. Every 30 minutes, he was going out on patrol and then going back to his office, which is very irregular. No one goes patrolling every 30 minutes. The evidences that were collected was shoe size number 9 that was stored just outside the gallery number D, where the painting was there. And shoe size number 9 matched exactly Vikram Singh. That could be his own shoe. He also had family connections of illegal antique trade. His brother Gopal Singh also had an illegal antique trade, so that he knew exactly what are the buyer networks, where he can sell the painting, and he had all the access and all the evidences finally lived up to Vikram Singh.
All right. The suspect number 2 is Meera Joshi, who is the art appraiser. So Meera Joshi was former gallery owner, and the painting, the Nilgiri Taj, was actually valued by Meera Joshi, and the valuation was 14.5 crores. Then also there are some suspicious activities done by Meera Joshi, and one of them is she called a Belgian number, and which is suspicious. Like she has an extensive buyer network, so she might have tried to connect to the buyers, and she might have a plan to steal the painting and sell it to them. The another thing is when the night before the stealing, she has tried to access the door number 6, exactly where the painting was there. And also she was owning the gray Mahindra Bolero, and the same car was seen by our night watchman Pawar, and the at the same time of the theft. Also, the she was under very financial pressure, so she has proper motive, and she has proper network by network to do the stealing. So she is suspect number 2.
And suspect number 3, and the final suspect, is Rohan Kulkarni. He was a junior curator and a restoration specialist. He had skilled hands, he has restored a lot of paintings, and he even had restored the Nilgiri Taj just a week before a whole conference happened. He had the after hours access, that means with his badge, he can access the whole painting at night. Also, one important key fact is that he did not attend the conference. He had taken a leave to go to a Hyderabad trip. But on police investigations, it was found out that flight number 6E404 that was booked by him for Hyderabad was cancelled. He still did not inform the museum authorities that his travel plans had cancelled. Also, upon further investigations, he did not make any other travel plans, any buses or trains to go to Hyderabad. Also, on the night where the painting disappeared, there was no whereabouts, and the whole police investigations was not able to uncover where was Rohan Kulkarni when the painting was stolen. He was a conservation specialist, so he could be skilled, and he was the one who knew exactly the value of the Nilgiri Taj. So just take a moment, just think about the 3 suspects: Vikram Singh, Meera Joshi, and Rohan Kulkarni. And in our notepad, just write down the name, just a wild guess who could be the final culprit.
So these are the evidences, like just to show you that witness statements, then the forensic report and the security event logs we have the police have collected. Now it lands to the chapter number 1, the obvious answer. Meet Sub-Inspector Karan Bose. Sub-Inspector Karan Bose is 28 years old, and he is in Mumbai Crime Branch, and he has solved 23 cases, and the key thing is he has solved all the cases in just 5 minutes. So he'll just look at the evidence, and he now just gets his answer in his mind in just 5 minutes, and he runs on his instinct. And now he has this case, the Nilgiri Taj file, on his desk, and he is the one who is now going to solve this case. But still, he is not worried, because he never gets worried, because he just has an answer by looking at the evidences.
So why is not worried and what are his instincts? Let us see. The only one question came to the mind is who stole the Nilgiri Taj painting from MIFA Mumbai? And that's the only question he started the investigation from. Now, his way of investigating is fairly simple. He searches the whole clues, all the documents, and then he retrieves the top clues. After he retrieves the top clues, he goes through all the clues and then he has the answer. He just has his instincts. He does not verify. He knows his answer and he thinks that he knows everything. Let's see how he exactly investigated the whole case and what was the final conclusion. Sub-Inspector Karan Bose had the top clues. From all the documents that he had seen, he had gathered out the top clues that were most semantically similar to the question, who stole the painting from gallery number D. He just starts the investigation, and just one disclaimer, he is really fast. He just searches who is the primary suspect, he looks at all the clues, and directly gives the answer that the primary suspect is Vikram Singh. There are a lot of evidences that he had seen, and finally he will uncover why is it Vikram Singh.
All right. So verdict of Karan Bose, you have seen that is Vikram Singh. The reasons he has stated for that was he has all the access to the codes. He was already there on the site for 12 years, and he was on the suspicious routine night check. And some of the witnesses testified against him, and also shoe size matched Vikram Singh, and he also deliberately lowered security at that night. So all the clues are pointing towards Vikram Singh, and now Karan Bose just has his answer, that is Vikram Singh.
So Karan's method is called a classic RAG pipeline. He goes, he just does a query, he embeds that query. He also has all the top clues embedded in the vector database. Then he just finds the top K chunks, the top 20, top 50 chunks, and he just thinks about it and gives the answer. He calls it efficiency. He thinks that one search, one question, one answer will always give me the correct answer. Because my question is right, my answer always have to be right. But okay, so just one question. How many of you guessed Vikram Singh?
Okay.
3 people who guessed Vikram Singh. Any guesses, Anshuman, why you thought it's Vikram Singh? Also, can you please explain your name and what are you doing right now?
I'm Anshuman Singh. I'm from MSU, and I guessed Vikram Singh because I was like for him. Like all the that Vikram Singh should be the culprit.
Okay.
Right. Anyone in the back wants to say why they thought it was Vikram Singh?
Hello, my name is Mayank Singh, and I also work as a software developer. So why I think Vikram Singh is a culprit, because the footprints, that is the major reason why I'm thinking that he might be the culprit. That's
right. So exactly your thought process was like Karan Bose. All the evidences lead up to him, the footprints lead up to him. Now let's uncover what was the answer.
Okay. So now the reveal is security log was the evidence, and Karan Bose never opened it, because security logs never matched as a top clues, and Karan Bose named an innocent man. The truth is, there were 14 consecutive entries of Vikram Singh towards his security desk, and those were every 13 minutes, and he was already there on his desk for every night, for all the night. So the Vikram Singh is not the culprit, and Karan Bose named an innocent man, and he ruined his life for some time.
So there are 3 reasons that he failed. What was the first one? It was that he retrieved only the top chunks. He overlooked that there might be critical clues that are lying in the investigation report that might not be semantically similar to the question he asked about who stole the painting. The security logs, as you might everyone might know by now, is that did not match semantically. A security log that I checked in at 11:45 does not exactly say that I stole the painting. That was the first. drawback of why the investigation failed.
The next thing is he trusted his first hit. Like whatever is the most prominent, most upfront is not every time right. There is something hidden inside those evidences, and he never looked on those things. And that was the drawback of Karan Bose, that he just follows the first hint and never looked into deeper.
And the third reason why he failed is that he just asked one broad question like who stole it. He could have asked a very concise and very direct to the point question, but that might not have given him the answer. He had only one chance, one attempt, and the top semantic chunks. That's why the question who stole it.
Okay, so something he missed was the security logs, as you know. So in the security logs, there was the badge 2247 written on that. And now the question is, who is badge 2247? Because the same badge 2247 has entered the door number 6 at the same time when the painting got stolen, and there was no alarms went on. So now the main question is, who is badge number 2247?
So by the time we start chapter number 2, those who had all guessed Vikram Singh, you have a second chance to guess anyone else. The two options are Meera Joshi and Rohan Kulkarni. So now we will start chapter number 2, going deeper. Meet Detective Aryan Sharma. Aryan Sharma has been a detective for quite a long time. He's 41 years old and he has relentless instinct. He is proved right on most of the cases. He has a high energy approach, but it takes his sweet time to find his answer. He operates by 4 unbreakable rules that we will just uncover now. He opens the Nilgiri Taj painting and Vikram Singh is already discarded. He already knows that Vikram Singh is not the culprit. What are the 4 ways that Aryan Sharma conducts his investigation?
Okay, so Aryan Sharma like now opens the case file now. So he like understand the objective first, that what has happened and what the actual thing and actual the how painting got stolen. So he understands the crime scene, and he understands the how investigation and all the evidence says. So he plans his investigation first by looking to the evidences. Then he searches and follows the leading clues. Like as we know in the security logs, there was badge number 2247. So that is a leading clue for him. So he tries to search for that who is badge number 2247, and somewhere in evidence that is already hidden. So he finds out those things and validates the evidences across all the sources. So once he finds that, for example, all the top leading clues were leading towards Vikram Singh, as you guys have guessed. So he was not following the top clues, but he goes deeper and he validates the evidence and just checks that whether these evidence are enough for the answer. If those are not enough, then he research in the evidence and then he gives his answer. And he never he never follows his first clues. So this is how Aryan Sharma starts investing. Let's see in live. So this Aryan Sharma, and he has these evidences like we have the police has retrieved, and the first is security log, and these are the security logs that has all the information who went where at what time. The suspect profile of our 3 suspects, Vikram Singh, Meera Joshi, and Rohan Kulkarni. All the details about them, all the background check, all the things are written in suspect profile. Witness statements, all the witness who were there at the crime scene at that night has taken into the interrogation, and they have logged all the statements in witness statements. Then the gallery inventory, that how gallery is designed, where is the which block is where, and everything, every detailed information about gallery is written in this. And the forensic report, the final evidence, and this has every detailed clue and whatever retrieved at the crime scene, everything written in this forensic report. So Aryan Sharma starts his investigation, deep dives into those evidences, and he starts looking for clues and for the leading clues mainly. So he thinks deeply about that. He now uncovers all the things. He's grading his evidences whether they are right or wrong, and he gives the verdict that Rohan Kulkarni and Meera Joshi has done this. Why? Let's see.
Now, there are a couple of reasons why Aryan gave this verdict. Well, his first answer is that Rohan Kulkarni is the primary suspect and Meera Joshi is the secondary suspect. It was found out that badge number 2247 was actually Rohan Kulkarni. He also had no whereabouts during the theft. If he was in the gallery at night, but no one still knows where was he exactly during that night. He was found with a conservation scalpel. What is a scalpel? You might have remembered the frame was still there, but the canvas was gone. There was some intricate hands that were working to remove the canvas that night. Also, oil was found or door number 6. And since he was a restoration specialist, oil was something that was daily used in his office. Also, one more interesting fact is that shoe size number 9 UK was also of Rohan Kulkarni, not just Vikram Singh. Why Meera Joshi then? Well, there was a very peculiar thing that happened on that conference is that while leaving, she had tried to access door number 6. She did not have the authentication and hence the authentication failed. Then exactly why did she try to access? That is still unknown. She had met Rohan Kulkarni on 2 nights before the whole incident happened. She also had the same grey Bolero car that was spotted by the night watchman Pawar. The Bolero car also had a sticker that was there for Meera Joshi. I want everyone to remember the sticker of the Bolero car. She also called an unknown Belgian number and talked for about 11 minutes just on the night of the conference. And this is really peculiar. So, Rohan Kulkarni was in the building. He had all the means that he can steal the painting. And Meera Joshi, she might be the mastermind who could have told Rohan Kulkarni to do it. She had the buyer network. She had all the profits that she could have got by stealing this painting.
Was Aryan's method. This similar like agentic reg how agentic reg works. So first he takes his question. He does not just retrieves all the clues, but he finds the clues and reasons over there. He finds the leading clues over those retrieved top clues, and like he observes whatever he found as the evidence. Then he reacts according to what he found and what are the clues over there, and he now asks himself that whether this is enough to answer, or he just validates all the clues, and if this is not enough for the answer, enough for the verdict, then he again goes to the goes in the loop and again retrieves, then extract the information and then look over the information again and again validate. So he goes into the loop. As similarly how agentic reg works, that agentic reg also semantically search for the clues, then the agentic reg observe, the agent observe on those clues, and then agent again validates those clues using tools, and then again goes into the loop, and then it has the proper prominent answer, and which was Rohan Kulkarni and Meera Joshi. So Aryan Sharma was a skeptical, and he doesn't trust the first clue as we mentioned, and he reasons until he is not satisfied. So this was the proper method of Aryan Sharma. Now, how did he reach the conclusion? There are some of the things that he has followed. One is reason. Instead of asking the first prominent question that who stole it, instead of that, he just asked that who has the access to those doors, and the answer was Vikram Singh. Then he asked that who is suspicious right now. So Meera Joshi was suspicious because she called an Belgian number, and that is really suspicious. And then who has the skills? So Rohan Kulkarni was having the skills, and now asking these break question, he now has the all the information that he needed for that. So he was not just giving his verdict based on who stole it, but he asked multiple questions in by breaking them down.
Now just one broad question does not solve it, right? He finds everything. He had the tools of exactly how to retrieve those information. Then after the information, he asked the second question that is more direct. He asked who was in the building. Now, he first asked who was present overnight. Then there was Vikram Singh because he was a security guard, and that was night watchman Pawar. But they are not suspicious because they are there every night. The second question that he asked was who was there after hours when they were not supposed to be there. And that was badge number 2247. We will uncover later that badge number 2247 was actually found to be of Rohan Kulkarni. So he was then given the primary suspect.
Then the third thing is tool calling, collecting all the evidences. So he uses the right sources for each clue. Like he asks that where is the data, so data lies into the evidences, and he just finds the tool to call the suspect profiles, he has the tool to call the security logs, and he has the tool to call the forensic reports. That those tools were not present with our first detective, Karan Bose. So these are the extra things that Aryan Sharma had, and he learned these things, how to use them. And now using those tools, he found out that from the suspect profile, Kulkarni and Joshi made before the incident. Also from the security log, he found out about that badge 2247, and using forensic report, he found out that shoe size 9 UK and those chemical traces which were found at the crime scene. So using those tool calls really enhances his search, really enhances his investigation.
Now there is a limit. In the whole evidences, there were lying 4 images that Aryan Sharma did not see. One of those images shows a CCTV capture of a man in a black coat, something in his hand covered, going to a grey bolero. The second scene shows a man peeling off a sticker from a grey bolero on the night. All the CCTV captures were taken at 2:30 at the night when the painting was stolen. We also have a gallery floor plan that exactly showed how the conference was there. There is this restoration laboratory that had direct access to the main hall. There were gallery number 1, 2, 3, and the gallery number D where the painting was stored. And without any authentication, you can't go into inside the gallery if you are working as a restoration specialist. The fourth image is a screenshot where Meera Joshi had instructed Rohan Kulkarni to do an insurance audit for international insurance of the painting. So, by this additional 4 clues, any guesses on who can be the primary suspect? We will again ask after the session ends, but okay, just write it down in your notepad on who can be the primary suspect after the final clues are there. So, chapter number 3, the vision. Meet Inspector Priya Menon. Priya Menon was the senior of Aryan Sharma. She was in special investigations and the senior most person. She is 47 years old. One thing is that she was the supervisor for Aryan Sharma for 6 years, and she was the one who taught 3 of his 4 rules. She reads images like evidences, and through her experience, she knows that all the evidences are important to solve any mystery. You cannot leave out anything. Textual data alone is not something that is okay to solve the whole case. She picks up Aryan Sharma's investigation board. She sees the whole exactly investigation that happened, the culprit. She discards it. She said that this investigation does not open the image files. Then it is an incomplete investigation. She again starts her whole investigation from the scratch.
So he first looks at the existing investigation, and as he told that she realized that the key images were completely missed, and now she picks up those images along with the textual data, along with the textual evidences. She analyzes those images as well, and she reasons over those images, and now she has the clear idea that who is the culprit. Not just looking at the text, the Aryan Sharma was having 2 suspects, but now looking over the images, now she has the only one culprit who has done this task. So now she doesn't miss anything. She looks at every evidence, every single evidence that we have in the evidence box. So let's see how exactly Priya worked. Okay. So she is Inspector Priya Menon, and along with these textual evidences, she has the visual evidences as well. The gallery floor plan, CCTV footage number 1, CCTV footage number 2, where the man is peeling something orange from the car, and the evidence number 4, which is Meera Joshi's email. Now she starts the investigation. She takes her sweet time because she needs to analyze the images as well. So she is first looking at those textual data first, she was looking at Aryan Sharma's investigation. So she first look at those things, and then now she is looking at the visual evidences, searching the visual evidence where CCTV footage is there. Also, she is searching that some person is at the service gate and some peeling off something out of the car, and also looks at the Meera Joshi's email as well. and she has the answer, and she arrested Rohan Kulkarni. And now she cleared Vikram Singh and Meera Joshi. Let's see why.
So she slowly, quietly removes Meera Joshi from the whole board. The answer is very clear now. The case number 001 has been finally closed, and the final culprit is Rohan Kulkarni. Just a quick question. How many of you had guessed Rohan Kulkarni from the start? Just two? So everyone else was Meera Joshi or something?
Okay. Uh,
So there was a press conference, and she was explaining on why Rohan Kulkarni is the one who stole the painting.
Okay, so these are the statements that Priya Menon gave in the press conference, and the first statement is like Rohan Kulkarni used his restoration access to study the painting. He had all the skills how to remove the painting, how without like breaking the frame, and he has the access to enter the corridor, enter the door number 6. Using his badge because that badge was given a special access to enter that door. Also, he removed only the canvas and escaped through the service route to a waiting Bolero. So there was a Bolero found on the image, and that was exact same gray Mahindra Bolero, the exact same vehicle owned by Meera Joshi. So he framed Meera Joshi to like he used the similar kind of vehicle, and he was not peeling off the sticker, but he was sticking that sticker because Meera Joshi had the same sticker on that grey Mahindra Bolero. So he framed Meera Joshi. Also, he framed Vikram Singh because using Vikram Singh's petrol logs and admin access, and he took admin access from Vikram Singh for some specific reason, and he framed Vikram Singh as well. So he was the one who was the culprit, and he was the mastermind and framing everyone else apart from him. But the Priya Menon was the one who found out that this is the culprit. And because not just looking at the textual data, but looking at the images as well. So looking at the images really helps whenever your source has the image source or any other modality sources. All right.
So, what was Priya's method and how was it different than Agentic RAG or Aryan Sharma's method? That was not, to be honest, a lot different because she is just the senior of Aryan Sharma. She does the same exact loop. She first looks at the case, she acts on it and retrieves using a question. Then she observes and reasons over the question on exactly how the evidences might help to give her the answer. She then reacts. She has an option that she can just answer the question using the evidences that she got, but she also has the option to call more tools to gather more evidences, to gather the image data. On the React part, she had some tools that could easily gather the image data that were stored in the evidence box. And then she again, if she wants, she again acts, she again reasons over the question, she again gives the answer. So we are giving the whole power to the agent, not to the rack. We gave the rack system to the agent. The agent then decides which rack system to use and how to use. That's how agentic RAG is actually made. You give the power of RAG to an agent to reason, to decipher, to make decisions, and finally give an answer. Hence, she looks at everything. Now, how exactly she retrieves the images? She uses multimodal embeddings to retrieve images from the documents. She analyzes and she analyzes those images using textual data. Now, what is multimodal embeddings and why exactly she used that? There are multiple ways to have images in a RAG system. There is the transcription way and there is a multimodal way that we will uncover just a few slides later. But this is a way that we can add multimodality and images to agentic RAG systems to enhance it, to make it better.
Okay, so let's see some performance comparison of those detectives. So first is Karan Bose, Aryan Sharma, Priya Menon, who acted as naive reg, agentic reg, and multimodal reg. So what was the query strategy? So Karan Bose just go on one shot, like he retrieved just based on the first query only. He did not ask multiple questions, but Aryan Sharma was using multi-hop loop. So he asks multiple questions and he goes into the loop instead of asking just one short question. And Priya Menon was using cross modality queries. So she was not just querying the textual data, but she was also querying on the images as well. Now, how retrieval was done by those people? So retrieval for Karan Bose was just top K chunks. He just retrieved top clues instead of looking all the evidence in detail. But Aryan Sharma was using adaptive requeries, and using requerying all the evidences, he found out like essential clues from the evidences, and then he was able to give his verdict. But Priya Menon was also, as we said, that she was looking at the images, not just text. Reasoning part, so reasoning was not done at all by Karan Bose, and he just gives his answer in just few seconds. And because of that, he gave a wrong answer, because our case was not just upfront. The case was deep dived into the evidence. Then Aryan Sharma does something different, which is plan, act, and call. Planning how we need to find the evidences, acting upon that, and call proper evidences according to the query, and then reason over that. And Priya Menon just adds vision into the logic. Now, verification was never done by Karan Bose, and because of that, he answered innocent man, and he did not verify that whether he is the culprit or not. And Aryan Sharma always reasoned, always verified that whether the culprits are there or not, are those the actual culprits or not. And Priya Menon also does the same, because she was the tutor of Aryan Sharma. And the tool use, so tool was not available with Karan Bose. He was really naive, and Aryan Sharma used those tools to retrieve the evidences, and Priya Menon was having some extra tools which are able to extract and analyze the images. Now, results you already know. The wrong suspect was guessed by Karan Bose. The incomplete answer was given by Aryan Sharma, and adding the ability to analyze images, the answer was clear with Priya Menon, and case was closed now. So this is like evolution of RAG systems, that how RAG system worked on. So let's see next.
So before we start how to build agentic RAG, are there any questions about the case, about detectives, about the methods that were happening? We are open for questions for like 2 minutes and then we just resume the presentation. Anyone has any questions, any doubts? Okay, then we will just resume, and we are starting with the session number 2, which is how to build agentic RAG on your own. So agentic RAG seems like a very complex concept. You build agents, you have these different tools. You need to build the semantic retrieval systems, different kinds of tools to retrieve data from the documents. And what are agents exactly? How to build agents? Well, the whole thing might look a bit complex, but actually it is really very easy to implement agents on your own. So the first thing while building your own agent is defining your own tools. What are tools? Tools are something that is a function that you can use to retrieve information from the whole knowledge database. There are a lot of tools. Right now we had the retrieve documents tool and the grade relevance tool. Retrieve documents tool had access to different kind of retrieval systems like keyword searching inside the whole textual data, like semantic searching using cosine similarities, and much more. You could have just asked Karan and then he could have got the whole case of Karan as well. So you can also have a participant search as well. The plan of how to make a tools is infinite. You can be as creative as possible while defining your own tools. The second important tool that we gave in this presentation was a grade relevance tool. What happens is that when Aryan Sharma conducts his investigation, he can at last call the grade relevance tool to grade exactly how his investigation went and how was the answer. If the grade was above 0. If more than 0.6, then he was quite confident that my investigation went right or my investigation did not go right. The number 2 is assembling the agent. We have seen how to build tools, but exactly how to assemble the agents. It is also very easy. You can use frameworks like LangChain. You can use different LLM providers like GPT, Claude, and a lot more open source ones as well. You can just, in a LangChain, you can just use a simple function like create agent. You can just define the tools in one of the arguments. And all the tools that you have created, which are just basic functions, you can just assign it to them. And magically, the LLM knows exactly what tools to call and how to call. Behind the background, what happens is that the LLM is prompted to give the answer in an exact JSON format. It knows exactly how I can call a tool, what kind of format do I need, but that all is not important to build your own agentic system. To just get ready with it, to just experiment with it, you can just use frameworks like LangChain. You can use LangGraph to have a multi-orchestration layer as well. And you can just use one function to create your own agent, give it tools, and it magically calls it on its own. And a bonus over all this is multimodality. What is multimodality? You can embed textual data and the agent can read textual data. But you might have used a lot of agentic systems like ChatGPT, Claude as well, where you can also upload image data, PDFs data, and it is also able to answer only from that pictorial data as well. So we need that in our agentic systems. So exactly how to do that? So the LLMs, the current capability of LLMs is also expanded to images. So most of the LLMs can give imagerial answers, but you need to first select what kind of LLM you want to use. Then you can have an embed image function as well. So from the tools, you can just add one other tool is retrieve images, or you can just add the image capability in the document retrieval tool that we created. And how that embed image is working, there are two ways. There are transcription ways and there is the multimodal ways that I just explained. But by these three slides, I just wanted to tell you guys that it is so easy to create your own rack system. Define your tools, make the agent ready, and for bonus, give it a tool for embedding images.
So let's build the agentic RAG system live. So I will go to this. Okay, so let's go and build our own RAG systems, and we are going to build Aryan Sharma and Priya Menon, who is actually agentic RAG and multimodal RAG. So first installing all the necessary dependencies, and then we have used OpenAI as the reasoning LLM and the Gemini as embedding LLM, and we have used Gemini as multimodal for multimodal embeddings, but there are a lot of multimodal embedding models are available in the market, and one of them is Amazon, like AWS Nova is there. So, but for instance, we have used Gemini. So now we are giving all the evidences that we have, the police has uncovered, and we are giving them to knowledge base. And these are forensic reports, security logs, gallery inventory, suspect profiles, and witness statements. So we are collecting all those evidences in this, and we have our query that who stole the Nilgiri Taj painting. So this is the prime query that every agents, every detectives have asked to their system, but everyone got different answer. So this is the one query that will fire. The next thing is embedding function. So this is the embed text function, and that was available with Aryan Sharma because he was only able to look at the images. So he was only able to embed the text only. So also using Gemini embedding 2, we have embedded the text and stored in the vector space. We have used ChromaDB, but you can use any other databases available in the market. And we have added these evidences into the collection, and the collection is ready now. Now Detective Aryan Sharma comes in the picture. We'll just, as Arup mentioned, those steps to how to define the agentic RAG will follow the first step, which is write tools. So we'll write tools. One is retrieve document and another is grade relevance. So for POC perspective, we have just kept two tools, but according to your use case, you can define your own tools. Be creative and think through it. What is your use case, and think through it a lot, and then define your tools, because tools really makes a very huge difference in your agentic RAG system, because tools are those which enhances your output, which enhances your answer. Whenever we give it to agents, we give it to LLM, then LLM is able to retrieve the proper and correct answer instead of just hallucinating. Then we'll assemble the agents. So by just giving tools, that is not necessary. We also need to give a proper persona to the agent. So as Aryan Sharma was having a proper persona, we have given that persona through the prompt. So we have written a detailed prompt that how Aryan Sharma needs to work upon. He identified the most prominent suspect. He looks at the evidences, and then he looks cross reference across the files. He validates his answer. What he needs to do, what are his tasks to do and what is his method, we have written that through prompt. So we are also adding the prompt and assembling the agent and giving those tools to this agent, which is Aryan Sharma. Then we'll run the agent simply. We are running the agent with the query that we have defined, and query is who stole the painting. So using that query, we are just streaming over here, and it will stream the output. And we have seen that output was written, which was the verdict that two suspects were found by Aryan Sharma. Now Detective Priya Menon comes in the picture, and she has some extra ability, one extra tool, one extra ingest step. So with Agentic Reg, there was ingestion of textual data, but to ingest images, we have some of the extra tools that we have defined for multimodal agents. So this embed image tool that we have defined, and this using the same model embedding 2, Gemini embedding 2, and this is how it is easy to ingest those images. So we have ingested those images which were there in the evidence box, like those CCTV footages, gallery inventory image, and then the last was preeminence, but the third suspect's email that we have found. So we have ingested all the images in the collection, and uh, yep. The step 2 is some of the helpers that we have ingested the images, but how the LLM will able to analyze those images. So we have given some of the extra helpers to the LLM, that how to encode the image, how to reason over image and text. So these are the essential methods that we have defined, and using those methods, the LLM will be able to not just look at the image but analyze the images as well. And yep. The next is writing the tools. So we have added some of the extra tools. Existing tools like retrieving and grading the relevance is already there, but we are adding one extra tool which is retrieve image context. And this uses those helper functions and retrieve, and the another tool is analyze image evidence. So first one will be able to retrieve the proper image from the collection using the query, and the next another tool which is analyze image evidence will be able to analyze over the image in detail. So these are the two tools that we have defined for multimodal agents. And now we'll assemble the agent again, and the same thing, that same prompt that we have given, but with extra ability to analyze the image. So we have given this new prompt to the visioned LLM, and this exactly defined how preeminent works. So this is a detailed prompt that we have given, and we are assembling the agent now and then running the agent. So now Priya Menon runs, and she retrieves all the images and all the evidences, and then she gives her answer, and that answer is really correct, and really really she found out that who is the culprit. So by adding just one step, just adding the analyzing the images, you are able to now answer the question correctly. So same question was asked to different different RAG systems, but that same question answered differently because we have assembled those RAG system differently. But this is how easy to create your own agentic RAG systems. And yep, let's go ahead.
So there are, we explored exactly how to create textual agents and multimodal agents. But Hitarth just showed we can just transcribe and embed the images into one shared vector space. But actually, there are two paths to multimodal RAG. The first is the transcription path, and the second is the unified embedding path. We will explore both. So in a transcription path, you take your non-textual data, you can transcribe. Those data can be audios, that can be videos, that can be images, or any kind of data. You can transcribe those audios or videos, or if an images, you can just describe that images using an LLM. You can finally caption those images. So there can be diagrams. You can make an LLM describe it. You can describe it on its own. And then you can store it in the knowledge base with a metadata that it's an image. And the LLM can just retrieve semantically using keyword searches. It looks at the textual data. It reads the textual data. But actually, it is reading the visual data. So you are storing the image as a text in the whole backend. The second is the unified embedding path. What is a unified embedding path? You can map all the modalities into a single vector space. So in semantic retrieval system, what do? We embed a text, we store that text, and then we have a semantic retrieval system that says that this text and this text are semantically very similar. That's why they are the final answers. So there is a method, there are multimodal embedding systems, embedding models as well that have a shared vector database. So imagine you have a image of a boy throwing a ball and a text of that a boy is throwing a ball. Both will be retrieved at the same time. The only catch, you will need to have a model that is capable of reading images. So you need to have the selection of the model in that way. You can have a direct retrieval of the native media, and it also retains the visual features. When you just write, this is a boy who is throwing a ball, you just forget all the features. How old is that boy? How does it look? What is his hair color? And what does the ball look like? But if you have a unified embedding path, then you can retain all those features. There are obviously trade-offs and drawbacks of both the path that we will explore in the next slides. But you choose transcription for simplicity. It is very simple. You don't need a different kind of database. You can just store it in the existing textual database. Or if you want to have cross-model reasoning, if you want to have those intricate details still stored and still retrieved, then you can have this shared embeddings and cross-model embeddings.
All right. So now, when to upgrade your detective? So we have looked over all the RAG systems, but we need to really identify that what is our use case, and according to our use case, we need to find that when to use what. So first is traditional RAG. So when we need to use that? Whenever you have just one source or limited source, and you need to find the answer from that limited source, and by just asking one question, and when the sources gives the answer upfront, then you need to use the traditional reg system, because that is not too much complex. Simple Q&A, stable content, and you prioritize speed over depth. So instead of going into deeper into the source, but you need that you find your answer very quickly. So at that time, the traditional reg is the really upfront answer for you. And here it uses very low price, because just retrieving the context and just reasoning over the given context, the price is really small. So whenever you have some price cap, then you need to use a traditional reg system. But when to use agentic reg? So whenever you have multiple sources, and those sources are really in detailed and deep, and at that time you need some reasoning over the sources and over the questions, and you have the verification step needed at that time. So instead of just asking one question, you want to ask multiple questions and verify over those questions output, and then you find your answer. At that time you need to use agentic reg system. And it uses multi-hop reasoning, of course, because we have the loops over the our architecture. So at that time, whenever your sources are long and deep and more, then at that time the agentic reg is the best for that. And when to use multimodal reg, as you guys already know now, as whenever you have more modalities like images, videos, audios, and many more, then at that time the best reg system would be multimodal reg. And this does not embed the words, just not reason over the text, but it also reasons over the other modalities as well. So this is not a competition, guys. This is a progression. Whenever, according to your use case, you find your agentic reg system, your reg system proper. So whenever you find you have your own problem statement, then you upgrade your reg system at that time.
So there are some trade-offs and drawbacks of all the systems. We have seen the capabilities of all the system, but is multimodal RAG the best one, or is agentic RAG the best one? What to choose? Well, first we need to have it in mind. What are the limits and what are the pros and cons, right? So in traditional limits, it is very rigid. It is easily confused. It accepts hallucinations because only the top 50 chunks that it retrieves, it tries to answer only from them, and it fails on multi-step tasks. But does that mean we don't need traditional RAG? No. Your system might have a unified knowledge base. You might need to prioritize speed. You might need to prioritize cost. And in that thing, traditional RAG is one of the best systems that you can use to answer just a chatbot question, to have it on the website. It is unnecessary to have a lot of cost to make the user wait for a long time. And that point, the user experience is the priority and it must be adhered. That's why traditional RAG has its limits, but it still remains one of the best RAG systems that has been made. Now, what are the drawbacks of agentic RAG? We have seen agentic RAG as one of the best RAG systems. It can answer everything, but then why not to use it? Because it has high loop latency. A lot of times, you can see that it might take 5 minutes, 10 minutes if your knowledge base is really long. Right now, we just have 4 to 5 documents. You might not have around 1,000 documents. What happens at that time is that agentic RAG systems cost a lot. You might have a lot of cost from a single query. You might take a lot of time. Also, the increased token, there are a lot of tokens and there's infinite reasoning loops. There might be thousands of evidences that are happening, and agentic RAG systems might also hallucinate because of different and lot of data. Now, multimodal systems. We just explored multimodal. RAG gave us the right answer. It also did not take a lot of much more time than the agentic system. But what are the drawbacks? The drawbacks is the high cost. To analyze images with an LLM takes a lot of money. The design is complex. You need to have a database that is structured to retrieve images. You need to have tools that are structured to retrieve images, and you need to choose a model that can retrieve images. And the other problem is shared embeddings. You can just transcribe a video, audio, store it in a database, but the transcription steps is an extra complexity to your whole agentic system. And what if you just have a shared embedding? You just store it in the database using the same embedding. But the problem is that shared embeddings will always perform worse than embeddings that are purely textual. You can have those images retrieved through shared embeddings, but when you just try to have complex semantic searches, you might get low results. You might get low scores for texts that are very similar as well. So these are some things that you need to take in mind while creating your own agentic RAG systems. So sophistication comes with a price. And as Hitarth said, this is not a competition. According to your system, according to your use case, you need to choose the right method to integrate in your system.
All right, so let's look at some of the agents that are available. So first is React agent that we just saw, like think, then use tools, observe, and then again think goes into loop. So it reasons, and according to that, it acts. So first agent is React agent.
The second agent is a planning agent. Now, what's the exact use of defining this agent? In an agentic RAG system, it is not necessary that you just have one agent and one tool. You can have an orchestration of different agents. There is a library known as LangGraph, which is used nowadays a lot to have the great orchestrations between agents. So a React agent, as Hitarth said, thinks, uses tools, observes, and gives an answer. A planning agent can be used on the first step, which looks at the query, looks at the clues, and then plans steps on exactly how the React agent will retrieve the information from the whole knowledge base.
The another is reflection agent. So it will like generate the output from the semantic search, and then when the output is generated, it critique that output, criticize that output, and after criticizing that, it finds that what is lacking in that. So after knowing what is lacking, it will improve that. So not just retrieving, but like criticizing that and finding the gaps from that output. It will really help whenever you have this kind of use case. You must use these reflection agents.
Then there is a router agent. Well, you might have a system where there are around 10 agents, 15 agents, and you can't just invoke all the agents at once and then analyze the answer. It's a very cost expensive job. You can just have a single router agent that analyzes the query. It knows the context on exactly what the system wants to retrieve, and it routes to the exact agent so that you just have one agent invocation, and that agent is a specialized agent that gives the answer.
The next is multi-agent system. So as we know all the above agents, we can combine all the agents at one time and create our huge multi-agent system that plans as well, research as well, critique as well, and execute as well. So every use case, according to your use case, you need to define your agents, your like whatever, like for example, you need some planning agent, then according to the plan, you need to like criticize that or critique that. So reflection agent. So every agents, and on top of that, the router agent. So router agents will define that which agent to choose. So the multi-agent systems comes in the picture at that time.
Now there is the multimodal agent. You can have a specialized agent that only when necessary retrieves the images. You can have a router agent that thinks, okay, this query might need images, then it is handing it off to the multimodal agent that gets that images, or else it just has a textual agent. Now, these are different workflows, they have different reasoning patterns, but finally, the whole system that we are building is a retrieval augmented generation or RAG system that gets all the information from a huge knowledge base that enables the LLM to give the answer. So be creative with your rack system. You can have a lot of different systems. You can experiment upon them. Now, what is agentic RAG finally? Agentic RAG is we give the ability to agents. Agents can reason, they can act, they can make decisions, and we can give the RAG system to the agents. And together, they can find the correct information that is needed to solve any kind of case.
So now the detectives were there. Then the culprit was already found, but the case still remains. Why? There is one question that still remains. Where is the painting? So you create your own rec system, you find out into the evidences, and you find out the answer that where is the painting, and you find and give that answer to us that where that painting was retrieved from that.
Now, just one thing, that all the evidences that we had was not, the agentic rack system was still not able to find out the exact thing that where is the painting. We want you all to be very creative, create your own rack system, and then let us know where was the painting. We will validate if the answer was right or wrong. So we are now open for questions. If anyone had any doubts, any questions, how was the system? Yes. So we are open for questions about the case. Just don't ask us where is the painting.
Yeah.
Otherwise, we are open for everything. How to create your systems. We will love to hear if anyone is creating their own agentic systems, working on that, and you can share your own experience as well. Yeah. Anyone?
For multimodal agents, do we have something like whenever we embed an image, do we will be able to probe that particular image that if this image contains image of cat or something, because it's an embedding at the end, it might not be able to get us the information of what's there because it's not text. So will it be able to answer those things?
So the first is embedding. Embeddings are used to retrieve stuff. They don't have the exact knowledge of exactly what is there in the image or the textual data. When you're using a semantic retrieval system to gather stuff, you are asking a question, where is a cat playing? And then the embedding will find the exact image. So it is semantically matching it. And so you know that my question is 90% similar to image number one. When you know that my question is 90% similar to image number one, then you fetch the image from the database and then you give it to the LLM. The LLM does not see the embedding. The LLM just see the images. The embeddings are just used to cosine match the two things, and that's how you get the answer.
Can you please state your name and what do you do?
My name is Mohit Sharma, and I work as a DevOps engineer as well as work as full stack engineer as well.
Yes, thank you.
Any other questions about him? Right.
Okay, so you have the images. For example, you have the videos, audios, images, all of them, right? So you have two ways. One way is you like describe your image and have the text. You transcribe your video or audio and have the text. So at the end, you will retrieve text on your own. You create your methods to retrieve those text from those different modalities and then embed that text. The another part is you don't retrieve the text on your own. You just embed those modalities into the vector database directly. And the transcription path, the describing path is removed from the picture, and just vector database has the actual content in the database.
So just give an example. Mohit just asked a question. Like if I embed an image directly, will I get the exact intricacies of the images? So The question was that you embed the whole image in the whole vector database. You have a question, and then you search if the image matches semantically or not. That is the multimodal embedding part. In the transcription part, what you do, you take an image of a cat. During ingestion of the image in the system, you describe it using an LLM. You can describe it on its own. User can describe it as well. And finally, you are storing it as a text. And finally, you are embedding that text. So that image is first converted to text, and that text is embedded, and then that text is retrieved, not the image.
Metadata inside of the LLM embeddings.
Right. So a metadata is something that will help, like the LLM will know that this is a text, like a cat is playing, but actually it was ingested by an image. So you can store a metadata in the database with that text that this was actually a text made from an image. So the LLM knows that this was an image actually, I'm just reading the text. So these are the two ways. First, you transcribe it. During ingestion, you might have complexities. The second is the embedding path. It is easy because thus you need more tools while retrieving the images from the database. And you need to have a storage as well for that. Hope that answers your question. And can you state exactly what do you do? What is your name?
I study in Karnavati University, Gandhinagar.
Okay.
That's great. Nice to meet you. Yeah, any other questions about the detectives, about rack systems, about the case as well? We are open to everything.
Hello. Yeah, my name is Praful Prajapati, working as a software engineer in MasterCard. Okay. So my question is, if we want to compare two text files, how or a RAG system can be helpful. So for example, let's consider a simple scenario. We have one story, right, where a list of the requirement is there, and we have written the list of the test cases for that requirement. So we want to perform the gap analysis between the requirement and the test cases. So how we can design the RAG systems or maybe the agentic RAG to solve such a problems for the gap analysis?
Okay. So as my understanding, your question was that you have, for example, two documents and you want to compare those two documents, right? So when you are planning to define the agentic RAG system, you just need tools, then create your agent, then run it. So first tool part, which will retrieve those documents from database, right? Then the next is define your agent. So you need to define your agent prompt in such a way that your use case, which is about retrieving the data documents, and then compare those. So you need to define the proper prompt that what it actually need to do. And the next is run your agent with proper query that you have these documents, and we want to compare that. So by adding tools which will retrieve, and by adding a proper prompt, it might help your use case. That is my understanding, right?
Also, just the case that you said is that you just have one acceptance criteria and one information about the ticket, right? That is solvable by a normal RAG agent as well. And I think so RAG will be the perfect system to solve this kind of case. The problem is when you have 1,000 Jira tickets with 1,000 different acceptance criteria and different descriptions, at that time, agentic system that Hitarth just explained will easily solve it. You can ask it a question in which epic we did this kind of features, and it can easily give an answer to that as well. Right. So everyone understood the case, and there are no doubts about the case. Who was Priya Menon? What was her past experience with detectives and anything? You can also ask about the presentation of how we came up with this story, and yeah.
I had just a small confirmation that for the transcription method, it's the one time only when the image will be processed and the text will be saved. And in the other approach, it will be all the time. Whenever user ask any query, the images are going to be analyzed.
Yes.
Right.
Yes.
Okay, okay.
Your name and what?
I'm Jaideep Surelia, working as a software developer.
Okay. Thank you.
So that answers the question why the transcription method is cheaper than the unified embedding method. Yes.
Yeah. So I wanted to ask if the dimensions of embeddings of both the multimodal and the textual data is same, and is it stored in the same database or in different databases?
It will be in the same database, and the dimension of the images and text will be the same at the time.
So finally, what happened in when you are embedding an image is that you take a vector of a fixed size. That vector is stored, for example, 1024 or 3000 dimensions. And then you store any kind of data. It can be audio, video, images, and you just give the semantic meaning to that fixed size.
It always queries the embeddings only, right?
Right. Yes. So that's why you don't have different database because the size is always fixed. Any other questions?
Hi, I'm Raj. I'm a software engineer. Since, first of all, great presentation. And since you really want to talk about it, I'll give you your question. How did you come up with the presentation?
So we brainstormed that how to explain agentic RAG in a simpler manner, that instead of going into pure technical thing, we just wanted to deliver it with a creative way where everyone can relate. So this was the idea that I was actually brainstorming with Claude Code, honestly saying. So I was finding that what can be the easy way to explain them. So this was the idea that I found out there.
We also watched Dhurandhar recently.
Yeah, so detectives were the...
Thanks.
Any other questions before this we wrap up these questions? I also love to hear your feedback, what you learned from it, what you want us to improve, and we are open for any kind of questions, suggestions. Yeah.
I'm Rajendra. First of all, great presentation. My question is more around the limitation with multimodal RAG, because what I think is the example and metaphorical case that you have taken, basically it still hides a perceptive details of what is going on in the case, which is still not visible with even multimodality. So what are the drawbacks or what are the challenges that you might face with this, and are there any techniques to overcome those challenges, which is like perceived statements or for example, you took an image, right? Someone is peeling off the sticker or someone is putting it there, is not visible in the image. Even if as a human I see the image, I can probably understand what is going on. But as embeddings are again pure mathematical representation of what is going on in the image, what do you think is a real problem with this limitation? And are there any techniques to have that perception? Because most of the cases does not get solved by only this mathematics that we have.
Okay, so my understanding is when we look at the image, actually, like I am looking at the image, right? So when you look at that image, that the person is peeling out or putting the sticker, right? So at that time, we are not able to understand that what the person is actually doing, peeling off or putting it. So when we give it to the LLM or store it in embeddings, the semantic meaning will be the same. Like some person is doing something with the sticker and with the car, but the actual intent of the person is still hidden inside the image. Like we are actually not able to look at the perceive the image actually looking at that. So that will be always hidden because that is the image. It is not a visual, graphical video that the person what is actually doing. So in context of the image, that can be the hidden inside that only.
So one other thing that I would like to add is that in this scenario, it was a highly specific one. It knew exactly what kind of images it had. But there is a scenario when you have 500 images in the whole database, and the agent might not exactly ask the question CCTV images. So there is a way where you mix the transcription and the multimodal embedding path. You first describe the image in a very detailed way, and you store those chunks in the database, and you query around. You make 100 chunks out of one image, all exploring different kind of meanings of that image, and then you find the cosine similarity. So that it is very possible that even if a agent asks a very broad question, that image can be retrieved as well.
Thank you.
Yes, thank you.